Okay, today, and I'm going to listen because I saw this. Actually, I might change up the music I'm listening to in a minute. But uh, today, I'm going to work on converting some grid rendering into geometry node scripts. So let's take a look at this. And actually, I am going to change up the music. I kind of want to listen. I was listening to Mike Keneally yesterday. Today, I'm going to listen to some more Keneally. This time we'll listen to the album Nonkertompf. Um, all right. It's a bit of a challenging album, but hopefully it'll get me in the mood for um, coding this stuff up. All right. Let me get fully set up here. Okay, so we are going to use the geometry node scripting that I did in a couple videos ago. Um, what this does is yesterday I was working inside the geometry nodes area, and that's a nice easy way of coming up with this visual programming. Um, like for instance here I can come up with some primitives. We'll do a cone right here and we'll output the cone instead of the cube, and that's nice. What we're going to do instead is I have a much easier time coming up with excuse me, I'm going to be drinking some off-brand Dr. Pepper. This is Dr. Lou. I had a friend in graduate school who was super into off-brand Dr. Peppers. He actually kept a collection of them in the grad student lounge or office. It was pretty rad. Okay, I'm going to be doing this here inside our Visual Studio Code environment. So let me move this one over here. This is my basic idea for our grid creator. I've created an input group here, and the way that node tree script, and actually this is a fork of that, it's like geometry tree script that makes nodes for everything in the compositor, the shader, all that stuff. You can create an input group, you can give it names. I'm going to create a grid specification, and actually I'm going to go ahead and get rid of these items. This grid specification is going to be an input group, and it's going to take a left edge and a right edge. Now you might think this is degenerate with a box, and it is degenerate with a box, but we are going to, instead of, well, actually maybe there's an even better way to do this. Is it possible to take meshes and make points and take, let's see, vertices or edges to edge paths to curves? Oh, you know what? Maybe there's an even easier way to do this than I was thinking. So let's do mesh. Let's come up with a cube. We'll come up with a primitive cube here. And now from this cube, let's do curve. Operations. Wait, was it curve? No, it was mesh. Edge paths to curves. Let's see what that looks like. Let's see. This I don't think actually changes anything, but let's see. We've got our curves here. Let's take a look at over here. Edge paths to curves. Well, there's probably a way to do this, but I guess I don't know the proper way. So let's take a look. If I remove this, mesh to geometry, we've got vertices, edges. Yeah. Face. Yeah. So here, if I drop this down, here are my edges. So I should be able to create well, here, let's do this. Mesh, operations, edge paths to curves. Yeah. looks like that doesn't totally do it for us. So that's a little bit strange. I would have expected that to work. But here, let's see if instead, if I now instance some points along this curve, let's do curved points. We'll do lots of them. Yeah, still not getting anything. So there must be something here that I am not understanding. So that's probably there we go. That's what I wanted. Mesh to curve. Yeah, okay, because it's not really edges, is it? Yeah. Now, one of the things that I am increasingly aware of in doing all of this here, especially in public like this, is that there's a lot I don't understand about the notation and the terminology used inside Blender, and I make a lot of mistakes. So let's go ahead here. Let's see if I can inspect my curve. We have 12 different splines here. So what we want to do is let's take our curve and let's see if we can make it so that our each spline, each of our individual splines, let's see if we can make that into its own individual instance. Let's see. That's not what I wanted. So let's see. We've got our curves. Let's see. Operations. Curve to mesh, curve to points. No, we don't want that. Actually, let's see what curve to points looks like here. Let's see how the points are distributed. So count 10. It looks like it's actually doing it each individual curve. So here, each point, and there should be some duplicates if I'm understanding this correctly. -5, -5, -5. Yeah, okay. So it looks like each one is its own individual item. So let's see if we can add an attribute to it. Now let's see if we can read our geometry index. I think that's what we want here. Name curve index. Okay, so let's see. Am I able to see my individual attributes? Probably not yet. We'll need to go to materials for that. Now, in a moment, I'm going to come back to this, and we will develop a script that does this, because it turns out one of the major advantages to doing stuff inside Geometry NodeScript is that we'll automatically convert mathematical formulas, which is hugely helpful for some of the stuff that I want to do. Okay, so here, let's go to shading. We're going to apply a material to our curve. Now, in the past, whenever I've done this, yeah, see, I don't actually want that. Let's do viewport shading. We are going to output a color. Let's see, we want this to be on a ramp, color ramp. And I kind of wish I had some color maps in here. I guess that's something that I could try doing with the shader. Okay, so let's map it. Purple, we'll add a couple control points. Purple down here. We'll add one in the middle, and that one will be blue. So we'll duplicate it. Make another bluish one over here. So we should be able to see some variation here. So this color goes into our base color, and then we will feed into it a factor, which is our attribute. We'll go there, and our attribute is, what did I call it? Curve index. Oh, but we got to map that because there are 12 of them. 4 for the bottom, 4 for the top, and then 4 to connect. We will map that. Converter map range. Let's see, I should be able to stick this in between. Yeah, there we go. From minimum 0 to max, from max 11 to that. Okay, and so now let's go on back to our geometry nodes. We'll set our material here. Let's stick it in there. Geometry material will be that one. So now let's see if it actually shows up. Now, one thing I have noticed in the past is that as soon as I do anything like this, sometimes it crashes, sometimes it just takes a long time, and I have no idea if you are still able to hear me, or if I'm still transmitting, or what. Okay, looks like it did eventually do it. Probably had to, I don't know, compile some shaders or something. So now we should have different line colors for each one of these, but it looks like we don't. Curve index goes in there. It's a float. Let's see if I can thicken this material up. Curve. All right, let's see. Primitive curves. No, that's not what I want. Maybe if I turn it into points, I'll be able to make sure that it's actually yeah, all right, so curve index is not doing anything here. So let's see if instead, if I set the curve index to 1, if I set the curve index to 4, yeah, all right. So curve index is doing it, but it's not being stored as an attribute. This index value here. Oh, hold on, is it? It is. Here, let's see if I skip this over here. No. All right, let me go ahead and join some geometry so that we've got both. So my line's not doing it, but then again, I wouldn't necessarily expect the line to do it. But I now have a grid with individual points. So now what we want to do is we want to take out the original curve. Well, we will do that. And then here we will do, we've got nx ns.int. Now I don't like doing this just because it's, I'd rather have it just be a vector, but I guess that's fine. So we've got box as points, and we'll say this as grid as points. Okay. So we've got a cube. Cube equals gs.cube. Size. Spec.size. spec.left, I'm sorry, spec.right edge minus spec.left edge. Now let's take a look at what this looks like first. Now remember, I had to set this up by going here into text editor, and I've added my geometry script item. So grid creator, that's our latest one. If I run this, I should now get a grid as points entry here. Oh, but I did not. Oh, size colon. I want size equals. So now we reload from disk. We run it. Now if we look at grid as points, there we go. That's fun. Let's go back to geometry nodes. We'll continue to convert. We've got curves equals gs.mesh to curve cube.mesh. Points equals that, but first we need to store a named attribute. Store a named attribute on curves. Nope, not nx. Name is curve index, value is reading the index. Now, I don't remember what material index, sample index, index switch, index of nearest, index. That's what we want. Okay, so now we've got our 3 items. Yep. Now let's do curve to points. Points equals that. And actually, you know what? Let's do this. If we call it on that, then it should. And actually, let me check to make sure that it does work. Which line? 17. Okay, now it's failing on. All right, you know what? I don't remember specifically how to do this, so let's keep this in multiple lines here. Geometry equals that. And I think that needs to be called. Okay, that's just a flake8 error. Let's reload this. Got multiple arguments for primary. Oh, right. Curved points. Curve equals that. Multiple arguments for primary. Geometry equals. Okay, now it executed. Let's see what that looks like. So far, so good. I don't know why UV map is showing up. Oh, because we're returning the entire cube. If I do that, then it should just be the mesh. And that mesh, do I actually want geometry? Nope. Okay. So what did I have to change here? Geometry equals that. Mesh equals that. Okay. So we've got names for everything. Join geometry. Geometry equals. Reload. Line 20. Points equals. Man. Having to name all these arguments. I'm sure there's a better way to do this. There's something in the documentation, or maybe it changed in Blender 4. I don't remember having to do this before. Return CLS. node socket geometry has no attribute default value. Let's try just returning points. That worked. So it is returning points. Let's see. Cannot express values type node socket. Okay, so there's clearly something weird going on with this that I need to address. Let me see if I can figure out where these named arguments are going awry, because that seems to be the main issue here, that in some situations I need different named arguments than I'm getting. So if I rerun this, let's see, node input.default value equals value in set or create link. Node socket geometry object has no attribute default value. Okay, so but I can't see what they say. Maybe just problems. Okay. So let's go back here and let's see if there's any examples. Geometry equals get socket of singular output. All right, let's take a look. No examples use that. Alright, this should help me understand where the error is coming from if I split things out onto multiple lines. It is crashing in. Cannot express points. Oh, yeah, of course. Alright, let's go back to the examples. Take a look at what they do here. So, typically what gets done is you'll see we do things like, see this is a yielder. Return mesh to volume dot instance dot merge by distance. Yeah, they're not actually doing any geometries or anything like that. This is the material one. That's a nice one. Now, how was I doing this in previous versions? GS volume cube instance on points. All right, so now it's returning points. Points.mesh doesn't exist. I guess I gotta name it. So see if this will do it. Join geometry with geometry's curves.curves. Has no attribute curves. That one's a mesh. Just curves. Okay, that did it. Alright, so now let's see. If I go here to geometry nodes, let me get rid of all this crap. Let's add a group. Grid as points. So we got left edge, right edge. I'm just going to set this to 1. Now we'll do an output. All right, so we now have our grid as points. Let's see. Let's go ahead and change this so that instead of returning the joined geometry, because we may not always want that, let's return a named output points, points, curves, curves. So let's reload, rerun. Now, let's see. Has no attribute mesh. What was it before? Is this it? Dang it. I forgot what it was. Points.points? Yeah, okay. So now I should be able to do Alright, let's see if this will do it for me with the points.points. It does. And I can switch between the two, or I could put a join geometry here. Okay, perfect. So we've got our points. And I'm going to see if I can construct my material now in that. Did we get the, hold on, let's see. One named attribute. What is the named attribute? Curved index. Oh, awesome. So grid as point, store named attribute, curved points, grid group output, yep. So let's try constructing a material shader inside our script. Now let's take a look at our material shader over here. Color ramp is going to be an interesting one. So import node tree script.api.material. Actually, I don't need that. I need SS. How did it know I was going to say color by curve index? Okay, so we're not going to do this. instead, we are going to say ss dot color ramp. Now here, this color ramp is probably going to be the tricky part in figuring this out. So let's see how we can come up with an example here. Let's see, any of this do material? Nope. Any of this do material? Nope. This does material. That's not what we want though. Alright, let's see if we can come up with our color ramp. I am going to hop on over to my Chrome instance, send it over here. Alright, color ramp, here we go. Signature, pointer to a color ramp. Whew, that's not fun. So let's see, how do we come up with that? Because we want to be able to add stop points and so on and so forth. This may simply not work. Let's take a look at this. This might be where we bump into the limitations of our node tree scripting environment. Let's take a look at the source just in case, because I think it generates a lot of stuff dynamically. Yeah. It may not be implemented. Let's grep for it. Yep, that's all got pointer. I'm getting the strong impression that I can't do it with this because it's not, the API is not quite exposed. So let's skip that for now. Now let's go back to our, let's see, I had a gravity source blender. What I'm going to do is I'm going to take, and this is kind of a, it is a really crummy gravity source. So let's go here. Don't save this. Oh, volume gravity, I think I did better. Yeah, there we go. Now let's convert this. Ugh, I forgot it was doing that here. Okay, we're going to convert this into a script, but just the parts we actually want. We've got this instances on points. We're going to convert gravitational force into that. So, gravitational force. We've got our position. So group input is a geometry. All right, so now let's do class gravity source, or gravity input, ns.input group. What we need for this is we need magnitude, source. Position. And now we need something to apply it to. So, sync position. No, I think we will do, I want to call this like, we'll just call it geometry. Alright, so now, ns.tree compute gravity. What this is going to do, actually, we will say apply gravity, because we are going to modify it. Nice try, Copilot. Now, some of these, we've got multiplications and additions and whatnot. We're going to need to use distance properly, so I don't remember if, so a bunch of these are going to get wrapped right up into it, so that's great. Okay. Apply gravity. The first thing we're going to do is we are going to compute the distance. gs.distmath. Oh no, distance. Maybe I want that to be math. Operation is distance. And let's see. Is it A and B? Let's go over here to our documentation. Geometry documentation. Vector math. Okay, so up to 3 vectors go into it. So okay. Nope, it's vector. Inputs dot source position, and then geometry dot position. Why is that? No parameter named vector. What? There we go, vector math. Okay, so now we've got that vector math, and that's the distance. But now we can also do some maximizing, and then we can also just apply some powers and whatnot. So this distance is now a value. Now why is that? Here, let's try returning this. So now this, if we execute, should give us, and then over here, let's go to Actually, it'll be easier if I finish converting the whole thing and then attempt to debug. So we got to apply a maximum. Well, we'll get to the maximum in a minute. We've got to power, multiply it by our value, return inputs dot magnitude times that. Actually, I should just be able to divide it. Yeah, FMM over R, okay? But now we need to multiply that by the vector. We'll call that value. Direction is equal to gs.position minus actually we need to normalize position direction is gs.vector math operation equals gs.vector math normalize. Huh, why is that not working? gs.vectormath.operation dot normalize. No, I just need to do vector equals gs.position. So now we've got our direction, our value. So we should be able to do return value times direction. So now if I execute this, and let me go ahead and create a new scene. No, hold on. I don't want to do that just because I've got all this stuff here. Okay, I'm going to start reusing position. So down here. Okay, so we've got vector equals position. Line too long. What? That's not a big deal. We have some more of my off-brand Dr. Pepper to celebrate. Alright, we've got vector as our position, return value times direction, but we actually want to offset it. So we do gs.set position geometry equals inputs dot geometry. Yeah, okay, there we go. Position equals pos plus direction times value. Return that. We're setting the position, we're doing our power, our distance. Alright, so now I should be able to create a new scene. Don't save it. Go to cube, geometry nodes. Go here, open up our script. Text editor, open. Grid as points. Alright, so now I'm going to guess we're going to get some errors. Yep. Functools.partial and float. Right, I think I need to do some value. Invalid operator, functools.partial. What if I do this? Wow. Did that do it? Alright, let's add a group. do grid as points. We'll have our points here. We will not do our curves. We'll do 16 along each dimension. Okay, so there we go. Now I should be able to apply gravity by creating a new group. Remember, I think this still does in the opposite direction from what we want. So we'll set our source position at 0. Have our geometry there. Check that out. Isn't that fun? And we can move the object wherever we want. Cool. So now we've got this. Now, the other thing I kind of want to do, I wonder if I can do points to curve. Huh. No, because it's connecting them. So let's do, I should be able to split them based on an attribute. Right? If I then read, oh, I want points to curve to happen here. Okay, but the group ID, should be a named attribute. So let's read a named attribute. Check that out. So it splits them. Oh, but yeah, it's not doubling up at the edges. So only one gets each edge. That's something that we can work on for another time, I think. So now if I move this, the curves get, I should be able to get it to the point where I can see the disjointness. Now if I drop this down to like 4, I should be able to see super blocky, but I'm not. I guess the splines take care of that mostly. Yeah. If I do 2, can I make it look boxy? Not quite, because it's splining them, so it's. But this is cool. Okay, so that's fun. now we've got our source moving, changing our grids. Yeah, you can start to see the blockiness, but I think there's still enough resolution that it works okay. If I reverse the magnitude, much more obvious here, especially because of the asymmetry in the source position. I'm not doing any clamping either. We'll reverse the direction here so that the magnitude, so that it always goes in. So this is fun. Yes, the next thing that we would want to do, and I really wanted to programmatically come up with a, what's it called, but I really wanted to programmatically come up with a color map. So I guess maybe the thing to do there is to take a look at textures. Because if I can come up with a programmatically created one-dimensional texture map, that should work okay. Let's see, can I create an image? Nope. In fact, the output from that isn't quite right either. Scale, separate color, scale, and we're going to need to do that at some point. But if I could create I wonder if people have done this with texture maps, or with these. So really what we want to be able to do is I want to be able to import matplotlib or CMYT, and grab all of the color maps and toss them in there as individual textures. But if I can't a priori create a texture, then I guess I would have to do that with either BPy or something, but I was really hoping to be able to come up with this. And the way that I would do that is create a bunch of stops in a color ramp, but the color ramps don't really work that way. Yeah, that's not it. RGB curves would be another way to do it, but I'm going to guess that RGB curves, much like the others, uses pointers and things like that. my read of that is that they have not implemented the API for modifying stuff like that. Yeah, see, mapping here is not the right thing. Maybe there's a way to get around that and to mix these different colors, but I'm not seeing it. All right. So to recap, we took some stuff in Blender, converted it into NodeScript. I'm going to add gridcreator.py. I'm going to add it to my BlendYT repository. Push it up. And what that lets us do now is we can execute that and get a grid specification node from which we can plot either curves or points. I am going to need to double up anywhere there are. I'm going to need to make sure that the points are duplicated at the edges. And that's might be harder than I would like. But I guess with that, I am going to call it a day on this particular project. So if you joined me, thanks for joining me. I hope this has been of help.